Very important example this is, and it is not so easy. You can see this example. Find the Fourier cosine transform of f of x is equal to is given. Student, please remember, write the formula correctly. In the Fourier series we have seen so many mistakes you have done, right? So this mistakes you have to avoid and write the correct answer. Is it clear? So okay, now you can see they have given f of x. Is it clear? So this is little bit different. Please be concentrated in for this example. You can say I will substitute the value f of x in this. So I'm going to take this as this is equal to integration 0 to infinity 1 upon 1 plus x square. This is our f of x, and this is cos s x dx. Students, is it clear? So now I can see, do we have any integration formula for this we can apply?
tan inverse of x.
Yes, nahi, like we used to have integration e raised to ax and then cos yes x we used to have, and then we used to have directly simplification, right students? Okay, but for this example, which is I already told you, this is quite different, and you have to practice such examples. Definitely such examples will come for your examination, and which is very very important. I would like to inform, because already it has appeared 2 times. Maybe this time it may appear. Yes students, now we don't have any formula for this integration. Please remember this. This is for this we don't have any formula. Integration is what, when we can apply the integration, students, you please remember, when we come across this standard integral sign, then for the standard value we can apply the integral sign, like tan is there. So tan inverse will be what, students? Tan inverse x will be 1 upon 1 plus x square. So such it must be a standard formula, as your friend said. But here you can see we cannot have. So what we have to do? We have to modify this now. So I can say that we cannot evaluate the integral directly. Is it clear? So I'm going to use the rule that is known as Lebanese rule. So please note down, this is very very important. Lebanese rule for differentiation. Is it clear? Under the integral sign. Now I can see we are going to differentiate this. So I will continue here. Differentiate this with respect to s. So wherever s is there, we are going to differentiate it. So I'm going to write here d by ds f of c yes. Is it clear? So now I'm going to differentiate. But what Leibniz rule says, whenever there is no integral sign, then we are going to take this as ordinary differentiation. Please remember, ordinary differentiation we are going to use. But when there is integral sign is there, and in this integral sign, variables, right? You can see here x is variable and s is also variable. Therefore, for such type of integration, we go for partial differentiation, that is dou upon dou s cos s x dx. So we have going to apply here in the integral sign it will be partial differentiation. Please remember why we use partial differentiation, students, because if there are more than two variable, automatically one variable will be constant we are going to consider, and we are going to take s as our value, that is function. So now you can see cos sx, x will become constant, therefore I will take it outside. Differentiation of cos x will be what, students? Yes, it is minus sine s x. Is it clear? So coefficient of s is x, therefore x I have taken outside. This is minus sine s x. Is it clear? So why I have done this? I have to modify this integral such a way that it should come in the standard form, and then I apply the standard formula from the integration so that we get the answer. So this step is quite important and it is quite different. Yes, only by practice you will get it, friends. Is it clear? So I'm going to substitute this value. So integration 0 to infinity 1 upon 1 plus x square I will take. Okay, so only this value will change. That is, here you can see minus is there. Minus I will take outside. So I'm going to write this as minus x sine sx dx. So already I have told you that in the Fourier transformation we cannot apply the integration in the first step. Please remember this. Is it clear? So you have to modify this such a way that you should get a standard integral formula and then substitute that value. Now I'll simplify this. This is equal to minus, I will take it outside. Integral 0 to infinity. This is x divided by 1 plus x square and sx dx. Now I can see I want to cancel this 1 plus x square, because in the denominator if any variable is there we cannot simplify this directly by taking this. So what I have to do, again I have to go for modification. Okay, so for modification what I will do, I will multiply, because denominator we have x square, so I will increase this power. Now what will happen, I am going to multiply and divide by x. So what will happen? This will become x square, and here I am going to take here x. Is it clear? So see here, once again I will repeat. I cannot modify this integration. I cannot apply directly the integration sign. Therefore, I am going to go for modification. I have used the rule for differentiation. Dou upon dou s cos sx is equal to x minus sine sx, or we also write this as minus x sine sx. So this I have substituted in this formula. Then again we have in the denominator we have x square, power is 2, but in the numerator we have only x, so I've just increased this power by multiplying and dividing by x. Okay, now again I have to modify this one, because again I cannot apply integration directly, there is no formula for this. So what I have to do, see in this in the denominator this is 1 plus x square is there, so I have to add here 1, right? So when I add 1 plus means if I add 1, then I have to subtract 1. So what I will do, add 1 and subtract 1. So add 1 and subtract 1. Is it clear? Now we can see in the numerator and denominator 1 plus x square is there, so I can cancel it very easily, students. Is it clear? So I will just put this in bracket. Okay. So this is 1 plus x square is in the numerator and 1 plus x square is in the denominator. Okay, then I will split this. So how you will split? Yes. So for this 1 plus x square, I will bring one side.
Excuse me, sir.
Plus, yes, beta.
Sir, it is minus x square.
Minus minus x square is there? No, beta. Is there here?
Sir, where you third step it should be when you multiply x to numerator and denominator, up will be minus x square.
Yes. Now I can see here. Once again, I will repeat. Don't worry. So lot of modifications I have done. So please be concentrated, right? We focused on this. I think it will go back till here. Okay. Now I can see here. I will repeat this step. Don't worry. So it is not so easy. I'm saying you have to practice. Okay. Everyone again. Once again, concentrate, please. So now I can see here. See, this is minus x sine sx is there. I have substituted this value, right? Minus, I will take it outside. So this will become minus integration 0 to infinity. This is x divided by 1 plus x square. Is it clear? And I will write this sine sx dx in outside this bracket. Is it clear till here? Okay. Now here you can see denominator we have power is 2. So I have to increase the power. So what I will do? I will multiply and divide by x. So this is going to become x into x, x square. And in the denominator, I'm going to take here x. Till here it is clear. Okay, so I will continue. So minus I will keep it outside the integration. The integral 0 to infinity is there. Because here you can see 1 plus x square is there. So I want to add here. Therefore what I will do? I will add 1 and I will subtract 1 and then remaining terms as it is 1 plus x square as it is, and this is sine sx dx. I think here till here it is clear.
Yes, sir.
Okay,
Yes,
thank
sir.
you. Okay, so here this modification you have to practice every time. Okay, so this is minus is there, integral 0 to infinity. Now I will just, instead of writing like this, I will just put it in this bracket because 1 plus x square must be cancelled. Am I right? So what I will do again, divide this denominator. So what I will do here, you can just see. Yes, everyone be concentrated here, students. Very, very important step this is. So 1 plus x square I will bring it one side and divided by x x square, and this is minus 1 divided by x into 1 plus x square. This is what I'm going to divide so that you can see this 1 plus x square and 1 plus x square will get cancelled. Is it clear? So now I will open this bracket and I will continue. Yes, I'm going very slow, students. Please concentrate on the steps. How modification I'm going to do. Till I get the standard value, I'm not going to apply the integration. Please remember this, students. So integration will be as it is. Integration 0 to infinity. Yes. Now here 1 is there, nothing is there means 1 into 1 plus x square is there. So I will take here 1 upon x, and this sine x dx I'm going to take inside this bracket. So I'm going to open this bracket, right? I will keep minus outside so that you will not get confused again. So here this will be sine sx dx. Here we have minus, so I will keep minus as it is. Integration I will take inside the bracket. So integration 0 to infinity. Here it is going to become sine sx I will take inside divided by x into 1 plus x square. Okay, so this is dx. Till here it is clear, students? Okay, so now you see, you remember that example, we know that integration 0 to infinity, right? Sine x divided by x dx. Can anybody tell me what is the value? From the first example, we have already solved this
Pi
example.
by 2.
Yes, excellent beta. It is pi by 2. So this is how we are going to modify this. Therefore, I will continue this step here. Yes, I think you remember first example, I think we have solved this. Integration 0 to infinity sin x upon x. I think we have calculated this as pi by 2. This is our first example. Okay, please remember. Okay, so from that we'll get here pi by 2. So therefore I will continue this. This is equal to minus, I will multiply inside. So this will become minus pi by 2. Minus into minus will become plus. Yes, friends. Here again we cannot simplify this. So I will write it as it is. Integration 0 to infinity sin s x divided by x into 1 plus x square dx. Is it clear, students? Okay, again further I cannot simplify. Right, students? This is d upon ds fc. Yes. Okay. To further simplify, I have to again go for differentiation. So once again, I am going to go for differentiate with respect to yes using Lebanese rule. Again, I'm going to use these rules, students. So what it says, outside the integral, it is ordinary differentiation, that is d upon d square upon d s square FCS is equal to minus pi upon 2 is constant, so therefore it will become 0. So it is not required to write. This is again integration 0 to infinity 1 upon x 1 plus x square remains as it is. Where is yes? Only that will. So this is in the integral sign, therefore this is going to become partial differentiation d upon ds sine s x dx. So as you know, students, what is d upon ds sine s x? Here x remains as it is, which is coefficient of s, and differentiation of sine will going to be cos s x. So by using this rule, I'm going to substitute this value as x cos s x. Remaining terms as it is, integral 0 to infinity 1 upon x 1 plus x square. This is going to become x cos sx dx. So lot of modifications we have to do here, students. Otherwise, it will become very difficult. I can see 1x will get cancelled in the numerator and denominator. Remaining integral 0 to infinity cos sx divided by 1 plus x square dx. Now what is the value of integration 0 to infinity cos sx divided by 1 plus x square dx? To bring this value, you can see this is already given. I think you can see here, that is integral 0 to infinity, yes, cos sx divided by 1 plus x square dx. It is clearly seen, students. You have seen, yes. So you can see why I have again differentiated, because I will get here this is equal to f c s, and this will remain d square upon d s square f c s. So for this modification, I have differentiated once again. Now I can write like this. The same equation I am going to write d square upon d s square f c s minus, I will just bring this value this side. It will going to become f c s is equal to 0. So now you can see this is second order differential equation. Yes, friend, because this is d square upon ds square. As you remember, that is using second order differential equation of the form. So I can make this of the form. I will just change its form. That is, I will just use d upon ds as capital D. So therefore, this is going to become d square. Yes. Here in this form there is no d, so I will just keep minus 1. I will take out common part, that is f c s is common, that I have removed outside. This is equal to 0. Now you can see this, friends. Can you remember how we can solve this? By using the auxiliary equation, we can solve this. Yes. What it will say? D will become m. So therefore, in the auxiliary equation, m square minus 1 is equal to 0. So because we want to find the solution, we can go only with the auxiliary equation m square minus 1 is equal to m. That implies m is equal to plus 1 or minus 1, students. So please remember the general solution of this equation when the roots are real. So what we get the general solution, students? Yes, therefore we get the general solution will be, that is, f c s is equal to c1 e raised to m1 s plus c2 e raised to m2 yes. So we can take from this m1 is equal to plus 1 and m2 we can take this as minus 1, students. Okay, now therefore I will write like this: fc s is equal to c1 e raised to s, because m is plus 1, then plus c2 e raised to minus s. You can see m2 is minus. Is it clear? Now this is our general solution, but we have to substitute the constant term c1 and c2. To find c1 and c2, I have to go again like this: to find c1 and c2. So to find c1 and c2, what I have to do here, students? Yes, correct. So again, what I will write: to find c1 and c2, I will take s is equal to 0. Okay, and I will simplify. But please remember, I will again differentiate this FCS. So I can write like this: d upon ds FCS is equal to, I can just denote it by f dash c s is equal to, you can see c1 is constant, I will write it c1. What is the differentiation of e raised to s? E raised to s itself. Okay, then you can see this is plus c2 is constant, but integration of minus, yes, differentiation of e raised to minus s is what we have: minus c2 e raised to minus s. Please remember differentiation of s with respect to e raised to minus as. Suppose if as is given, this is a into e raised to as. So you can see a is minus 1. So please remember this formula, students. Okay, now to find c1 and c2, see, this is our general solution, but I want c1 and c2. To find c1 and c2, what I have to do again? I will take s is equal to 0. So now s is equal to 0 means what will be? FC0. Yes, what is FC0? Okay, go to this equation. I will substitute here. Here only I will substitute. So it will be, there will be no confusion. FC0 if I take, this will be integration 0 to infinity. Yes, I can see this 1 upon 1 plus x square is there. So I'll write 1 upon 1 plus x square as it is, because s is 0. Please remember s is 0. So this will become cos 0. Cos 0 is 1. Therefore, fc0 will be integral 0 to infinity 1 upon 1 plus x square dx. So that value I will substitute here. So therefore this is integral 0 to infinity 1 upon 1 plus x square dx is equal to, yes friends, I will keep this c1, right, and as it is e raised to 0, e raised to 0 is 1, already you know. Please remember, you already used this e raised to 0 1 many times. Then this is again plus c2 e raised to minus 0, again you remember e raised to minus 0 is again 1. So therefore integral 0 to infinity 1 upon 1 plus x square dx will be equal to c1 plus c2, and continue here. So this is f c dash 0. Yes. Okay, f c dash 0, where I will get this f c dash? Already we have differentiated here. Yes, I will get the differentiation here. Am I right? So here only I will substitute so that it will be clear. So this I can d by ds is nothing but f dash c. Yes, I will take this. Okay, here I am substituting s is equal to 0. Am I clear? Okay, so now this is f dash c. 0 will be equal to, this is minus pi by 2. So wherever s is there, I am substituting 0, students. Is it clear? So now this you can see plus integral 0 to infinity sine 0 upon x 1 plus x square dx. So sine 0 is 0, and this full term will become 0. So therefore this is equal to minus pi by 2. fc dash 0 is nothing but, students, minus pi by 2. So I will substitute here. So this is equal to minus pi by 2. Is it clear? Okay, then this is equal to, again you can see this is c1. I am continuing here from this c1. E raised to 0 is again 1, so I'll write 1 only, minus c2. You can see here, students, e raised to minus, yes, again it is e raised to 0, it is 1. Therefore I'll write it like this. So further if you simplify, you can see this integration 0 to infinity 1 upon 1 plus x square dx. Can anybody tell me what is the formula for this?
Tan.
Yes, excellent. You are right. So I'll write C1 plus C2 is equal to integration 0 to infinity 1 upon 1 plus x square dx can be written as inverse x in the interval 0 to infinity. Can anybody tell me what is tan inverse infinity? That is not defined. Tan inverse not defined. Where it will come? 90 degrees. Am I right? Just check. Tan 0 is 0. So therefore tan inverse infinity is 90 degree. 90 degree I can write this as pi by. So therefore C1 plus C2 is equal to pi by 2. I will keep this as equation A. And then further if you simplify this equation, you can see this is minus pi by 2 is equal to C1 minus C2, or I'll write C1 minus C2 is equal to minus pi by 2, and I will keep this equation B. I am going to find only C1 and C2. So can you tell me what is the value of C1 and C2, students?
C1
Okay,
is pi by 2.
yes. So I will write C1 plus C2 is equal to pi by 2, and C1 minus C2 is equal to minus pi by 2. So I will just equate this. You can see plus C2 and minus C2 will get cancelled. Yes. Plus pi by 2 and minus pi by 2 will get cancelled. Therefore, this will become 2C1 is equal to 0, or C1 is equal to 0. So please can you tell me what will be C2? Yes, substitute in this equation. So we can see this is 0 plus C2 is equal to pi by 2. So therefore C2 will be equal to pi by 2. Am I right? Yes, friends, am I right?
Yes, sir.
Okay. So now I have to substitute C1 is 0 and C2 is pi by 2 in this equation. Where is that equation? General equation. This is our general equation. I will take it as star. So just substitute C1 and C2, finish. You will get the answer. Therefore, what is the answer? That is FCS is equal to, this is 0 e raised to, yes, is plus pi by 2 e raised to minus s, or if you further simplify, 0 into e raised to s will be 0. Therefore this is pi by 2 e raised to minus s, and here the function we have taken here 1 upon 1 plus x square, students. Is it clear? So this is how we have to simplify this example. Is it clear? Any doubt? Please ask me, students. Yes, students, any doubt?
No, sir.